capital. So NEF. There are different forces in nature. In mechanics, we will study different mechanical forces, but there are other forces other than mechanical. So the four fundamental forces of nature are gravity, gravitational force, number one. Number two, electromagnetic, which is the force between electric charges or because of the magnetic field. Three, the weak forces and the strong forces. These are the nuclear forces inside the nucleus. So the forces that hold together the nucleus. The strong and the weak forces. Okay, so the strong forces and weak forces is between the neutrons and protons inside the nucleus. Okay, those are the forces. Those the three forces, the last one, electromagnetic, strong, and weak, they are unified. For the most part, they are unified. The only force that affects the unification of the four forces is the gravitational force, which is the reason they are working now finding the Higgs particle or the God particle, and in the Switzerland and France laboratory, CERN. So probably you heard about the look for the God particle, which they are very close to prove that that particle, which is the Higgs particle, exists. And that is the only, and once that is founded, so the whole physics can be unified, because the gravitational force or the missing energy on the universe will be found, probably, and we can unify the four forces. So basically this is the idea. But today our concern is about mechanical forces, which gravitational force, the one that gives more headache to the physics community, is the one that we will study. The force, as I said, is that now the Newton said that all objects have the tendency to resist a change in the state of motion. And that property you can see here. So every object will have the tendency to resist any change in motion. So if I move this here, so you can see that if I move this, because this is a rest, eventually if I just move, it will try to go backward, because we want to stay in the same state of motion. That happened to us in a car. You accelerate, you want to move backward because you want to stay at rest. Then if you are moving, suddenly you brake, you go frontward because you want to keep the same velocity you have. That property is called inertia. So inertia is that property. It's the tendency of all objects to resist any change in the state of motion. That is called inertia. And what measures the inertia? The inertia is measured by the mass. So by definition, what we call mass in physics is the measure of inertia. This is the mass, and the mass will be given in kilogram. So, which object will have more inertia? A truck or a light car? A truck. So it's very difficult to brake. Why? Because the inertia it has. So it will have more tendency to resist the state of motion. So you have to go away from a truck when you are on the expressway. That is the reason. They cannot brake. As easy as a light car. As easy as a light car. So this is what we call the measure of inertia, mass. Now, if we have a mass, so from here comes the Newton first law, what we call the Newton first law. Newton is the second greatest scientist of, before up to the 20th century. Who was the first, considered by the scientific community? Albert Einstein, right? The second is Isaac Newton. Newton developed not only physics theory, but also calculus. So he's one of the founders of calculus. Okay, so Isaac Newton said that every object, so you don't have to write the laws are in every book. Every object in a state of rest or of uniform motion, moving at constant velocity along a straight line, will try to keep that state unless it is compelled to change it by forces impressed upon it. That's the way that Newton stated the first law. So every object will stay at state of rest or of uniform motion, moving at constant velocity, unless it is compelled to change the state by forces impressed upon the object. This is the way that Newton wrote the law, but this law can be written mathematically in this way. The net forces on an object will be equal to 0 if the object is at rest or if the object is moving at constant velocity along a straight line. This is the way that we will write the law mathematically. So if the object will be at rest if the forces is equal to 0, the net forces on the object. So you can see that this object is at rest. There will be several forces acting on this. What are the forces acting on this at this moment? Gravitational force downward, but this is not moving. You can see that it's not moving, so it should be another force acting on the object in the opposite direction. That is called normal force, which is force of electromagnetic kind, and that is coming from the ground, which is from the supporting surface, upward. So those two forces will balance each other, like in a tug of war, and none of them prevail, so the net force is equal to 0. This is basically this law. Along X, there is no forces. Okay, Newton's first law. We can write this is the vector form, but we can write this also in component form. We can separate the components. So the net force along X can be equal 0, and the net force along Y can be equal 0. It will be easier to solve problems working with the axes independently, X and Y, like we did in kinematics. Good, Newton's first law of motion. Newton's second law. The Newton's second law of motion, actually this law will be a special case of the second. And this law, by the way, is called, the Newton's first law is called the law of inertia. This Newton's first law is called also the law of inertia. So the Newton's second law, we call the law of acceleration. According to Newton, Newton said that the acceleration of the object is directly proportional. This means directly or proportional to the net force acting on the object, and inversely proportional to the mass. Inversely proportional to the mass. So it's proportional but inversely. 1/n means inversely, the reciprocal. The acceleration of the object and the net force always will be in the same direction. This is the way that we write the Newton's second law. The acceleration of the object always will be equal or will be proportional to the net force. If I apply more forces, the acceleration will be greater. And will be inversely proportional to the mass. So if the mass is greater, I have to apply more forces to have the same acceleration, or the acceleration will be less. Good. Now, in addition to that, always the acceleration and the net force will be in the same direction. This is very important part of the Newton's second law. Some people overlook this part, but it's important that the acceleration and the net force always will be in the same direction. Okay, good. Knowing that, we can write this, or Newton prefer to write this instead of this way. We prefer